All right, we're talking about spheres and hemispheres. So parts of a sphere, you're going to get the diameter. This one's going to be your radius. This one on the bottom is the center. This is the great circle. All right, so I just changed all of the lettering so that you could see it better. So this is your diameter. Your radius. Your center. And then the great circle is the one in center. Let's see. Is all of this. So if I was to slice it out, that would be your great circle. All right, let's talk about some formulas over on the side here. So you know that I would rather see this as 4 pi r cubed over 3. Much easier to do. The surface area is going to be 4 pi r squared. If you keep going down for the hemisphere, it should look like. Okay, so these are pretty straightforward. So for number 1, again, write the formula out. What's the volume? Because it wants the volume, it's r cubed. You know your radius. You can literally put that right into your calculator. So I did this first, multiplied it by that. And let's make sure we round to the nearest hundredths or tenths. Let's do tenths. And it's inches. Okay, so for number 2, I just want to point out this was the radius. For number 2, we have the diameter. So the radius is going to be 33 divided by 2, which is your 16.5. And then it becomes the same, the exact same type of problem. The answer for this is okay. To find the surface area, it's 4 times pi times r squared. We have our r. They're squared because we're doing surface area. Okay, for number 4, so this was the radius. For number 5, we have the diameter. So this answer, sorry, is okay. So for number 5, they gave us the radius, which is great. We want to find the volume. So volume is equal to 2 pi r cubed over 3. So 2 pi times 5 cubed over 3, 250 pi over 3, 261.8. Okay, so that was the radius. Let's go to the next page. Number 6 is now the diameter. So this whole thing's the diameter. The radius is going to be 18 divided by 2, which gives you 9. And then it ends up being the same type of problem. Which the answer is now to do the surface area. Oops. The surface area is going to be your 3 pi r squared. So we have our radius. So 3 pi times 14 squared. So our surface area is going to be 1,847.3 yards squared. This right here is your diameter. So we need to do the radius, which is 12.2 divided by 2, which is going to be 6.1. Becomes the same type of problem again. And our answer is 350.7 meters squared. You guys, that's it, literally. Let's talk about these applications. So for this one right here, if we're trying to, I'm thinking this is surface area. We're doing that for the surface area. We need to subtract out from the cone and from the hemisphere. We need to subtract that out. So, so if we do, let's see, so I'm going to let, I should say, we're going to let this guy be 1, we're going to let that guy be 2. So the surface area is going to equal pi r squared plus pi times r times the slant height. So we get pi times, if this is the diameter, 9 is the diameter, then the radius is 4.5. And the slant height is 13. So this ends up being because you have 2 pi's there, you can combine them. Which then gives you, actually we're going to leave it there. Leave it right there. I need to shrink this so I have a little more room. surface area for the hemisphere is going to be 3 pi r squared, which ends up being 60.75 pi. Okay, what I shaded over here, you can see my cursor, is the great circle. Okay, the great circle is basically just a regular circle. So to find the area of the circle, it's going to be pi r. Hold on, let's back up. We need to find the area of the great circle, pi r squared. That is what we're going to have to subtract out. This we're going to have to subtract out. So we take the 78.75 from the cone, add that to the 60.75 pi, and we're going to subtract out the 20.25 pi. Which, oh, there's a mistake. Not a big mistake. Minus 2 times that. The reason why you want to do 2 is there's one on the cone and one on the hemisphere. So this comes out to be 311.01 meters squared. Okay, I want you guys to try 11 and then come show me. I want you guys to try 11, come show me, and, or better yet, here, I want to see if you guys can get this answer. Okay. Cool, that's the end of the video.